Hello, good day everyone. This is Aldrin Murillo from the Mathematics Core, and here we are today for the second part of the first lesson in the Mathematics Core, which is about limits. Today we will discuss about the warm-up exercises as well as the exercises in the lesson proper. For the warm-up exercises, we are ought to find the values of a given function given a certain value. Number 1, for x squared minus 7 as when x is equal to 3, x plus 2 all over x minus 2 when x is equal to 0, x plus 3 plus 27 over x when x is equal to negative 3, 2 all over x minus 2 when x is equal to 2, and 8 plus the square root of 64x squared plus 16x when x is equal to 8. So the general procedures is to just plug in the value of x to the function. Number 1, for x squared minus 7, plug in 3 to the x value. So we'll have 4 multiplied by 3 squared minus 7, and algebra will follow. So the value of 4x squared minus 7 when x is equal to 3 is equal to 31. Number 2, do the same, plug in the values of x. So we'll have 0 plus 2 all over 0 minus 2, resulting to negative 1. Number 3, same, plug in values. So we'll have 3 multiplied by negative 3 plus 27 all over negative 3, which will equal to a negative 18. Number 4, do the same, plug in values. So we'll have 2 all over 2 minus 2, which is equal to 2 over 0. However, 2 all over 0 is undefined. So the answer for number 4 is NA, not available. And number 5, 8x plus the square root of 64x squared plus 6x. Just plug in the values of 8 to the x values. So we have 8 multiplied by 8 plus 64 multiplied by 8 squared plus 60 multiplied by 8. So we have 64 plus 8 squared 66. Now let's move on to the next exercises. So we are tasked to find the given functions, but at this time, we are just going to directly substitute the values. So number 1, the limit of x plus 4 all over x minus 1 as x approaches to 3. Simply plug in the values of 3 to the x values. So we'll have 3 plus 4 all over 3 minus 1, which will have 7 over 2. So the limit of x plus 4 all over x minus 1 as x approaches to 3 is equal to 7 halves. Number 2, the limit of the square root of 3 minus x as x approaches to negative 1. Just do the same, plug in the values. We'll have the square root of 3 minus negative 1, which is equal to the square root of 4, which is equal to 2. Number 3, the limit of x to the 4th power plus 3x cubed plus 5x squared plus 7x plus 9 as x approaches to 2. Do the same, plug in 2 to the x on the function. So we'll have 2 to the 4th power plus 3 multiplied by 2 cubed plus 5 multiplied by 2 squared plus 7 multiplied by 2 plus 9. So we'll have 16 plus 3 multiplied by 8 plus 5 multiplied by 4 plus 7 multiplied by 2 plus 9, which will equal to 83. So the next part of the examples is to find the limit of the given functions, but this time let's use the limit theorems. Number 1, the limit of x squared minus 8x minus 128 as x approaches to 4. So let's distribute the limit notation. The limit of x squared as x approaches to 4 minus the limit of 8x as x approaches to 4 minus the limit of 128 as x approaches to 4. Furthermore, let's use the constant theorem to evaluate the limit of the function. So we have the square of the limit of x as x approaches to 4 minus 8 multiplied by the limit of x as x approaches to 4 minus the limit of 128 as x approaches to 4. Now apply the following theorems to simplify the function. Now we have 4 squared minus 8 multiplied by 4 minus 128, which is equal to 144. So the limit of x squared minus 8x minus 128 as x approaches to 4 is equal to 144. Next, we have to find the limit of x squared minus 10x minus 10 all over the logarithm of x as x approaches to 10. Similarly, let us apply the quotient theorem to solve the following limit. Now we have the limit of x squared minus 10x minus 10 as x approaches to 10 all over the limit of the logarithm of x as x approaches to 10. Furthermore, let's apply the sum theorem and the constant theorem to solve the following limit. Now we have the limit of x squared as x approaches to 10 minus 10 multiplied by the limit of x as x approaches to 10 minus the limit of 10 as x approaches to 10 all over the logarithm of the limit of x as x approaches to 10. Applying the limit theorems, now we have 10 squared minus 10 multiplied by 10 minus 10 all over the logarithm of 10, which is all equal to negative 10. Next, let us find the limit of the cube root of x all over 1 minus the cube root of x as x approaches to 8 over 27. Apply the quotient theorem, and we have now the limit of the cube root of x as x approaches to 8 over 27 all over the limit of 1 minus the cube root of x as x approaches to negative 7. Now let us distribute the limit notation inside the cube root function, since we'll just derive to the similar answer. So now we'll have the cube root of the limit of x as x approaches to 8 over 27 all over the limit of 1 as x approaches to 8 over 27 minus the cube root of the limit of x as x approaches to 8 all over 27. Simplifying, we have the cube root of 8 over 27 all over 1 minus the cube root of 8 over 27, which will be equal to 2. And lastly, we have the limit of the quantity 20 minus x cubed multiplied by the logarithm of 1 minus 3x as x approaches to negative 3. Let's apply the product theorem, and now we have the limit of 20 minus x cubed as x approaches to negative 3 multiplied by the limit of the logarithm of 1 minus 3x as x approaches to negative 3. Furthermore, applying the sum theorem, we have the limit of 20 as x approaches to negative 3 minus the limit of x cubed as x approaches to negative 3 multiplied by the limit of the logarithm of 1 minus 3x as x approaches to negative 3. Simplifying and applying the following theorems that we used, we'll now have the quantity 20 minus negative 3 cubed multiplied by the logarithm of 1 minus 3 multiplied by negative 3. And further simplifying, we'll now have 47. Now, the next set of examples is finding the limits at infinity. So, number 1, we have the limit of 7x cubed minus 3x minus 1 all over 9x cubed plus 7x squared plus 5 as x approaches to infinity. Now, we have to divide the function by the highest exponent of x, which in this case, we have x cubed. We now have the limit of 7x cubed all over x cubed minus 3x all over x cubed minus 1 all over x cubed all over 9x cubed divided by x cubed plus 7x squared divided by x cubed plus 5x divided by x cubed as x approaches to infinity. Applying the quotient theorem, the sum theorem, and simplifying the terms of the function, we now have the limit of 7 as x approaches to infinity minus the limit of 3x all over x squared as x approaches to infinity minus the limit of 1 over x cubed as x approaches to infinity all over the limit of 9 as x approaches to infinity minus the limit of 7 over x as x approaches to infinity plus the limit of 5 all over x cubed as x approaches to infinity. Now, let's go back to the lecture. We have the notion at limits at infinity that the limit of any number multiplied by x raised to a given number is equal to 0. So, like technically, a number divided by an x term in which the x has an exponent. We can notice that 3 over x squared, 1 over x cubed, 7 over x, and 5 over x cubed all satisfy the notion I said earlier. So as the simplification, all of those will become 0. So simplifying, we have 7 minus 0 all over 9 plus 0, which will equal to 7 over 9. In number 2, we have the limit of 7x squared minus 8x minus 9 all over the limit of x cubed plus 2x squared plus 3x plus 4 as x approaches to infinity. Divide the function by the highest exponent of x, which in this case is x cubed. We now have the limit of 7x squared plus x cubed minus 8x over x cubed minus 9 over x cubed all over x cubed divided by x cubed plus 2x squared divided by x cubed plus 3x divided by x cubed plus 4 divided by x cubed as x approaches to infinity. Simplifying the function first will give us 7 divided by x minus 8 divided by x squared minus 9 divided by x cubed all over 1 plus 2 over x plus 3 over x squared plus 4 over x cubed. Let's apply the quotient and the sum theorem to further solve the function. And we now have the limit of 7 over x as x approaches to infinity minus the limit of 8 over x squared as x approaches to infinity minus the limit of 9 over x cubed as x approaches to infinity all over the limit of 1 as x approaches to infinity plus the limit of 2 all over x as x approaches to infinity plus the limit of 3 over x squared plus as x approaches to infinity plus the limit of 4 over x cubed as x approaches to infinity. Now applying the limits at infinity theorem, we now have 0 minus 0 minus 0 all over 1 plus 0 plus 0 plus 0. Now we have 0 over 1 which will equal to 0. So the limit of the function above is equal to 0. Now let's proceed to the final part of the series of examples in this lesson, the infinite limits. Now we are tasked to evaluate the limits of the following functions. Number 1, find the limit of negative 6 all over 4x minus 28 as x approaches to 7 to the left. Still applying the limit theorems, we'll now have the limit of negative 6 as x approaches to 7 to the left all over 4 multiplied by the limit of x as x approaches to negative as x approaches to 7 to the left minus the limit of 28 as x approaches to 7 to the left. Further simplifying, we have negative 6 all over 4 multiplied by 7 to the left minus 28, which is equal to negative 6 over 0 to the left. Now the catch here is the sign that is carried. Like if it is to the left, copy the sign, which is to the left, which is the negative sign. But if it's to the right, copy the sign. So since 7 is to the left, the result of the denominator below will be to the left. So it is negative 6 all over 0 with the negative sign. Now it is stated in the lesson that when the approaching limit is to the left, the resulting limit will be negative infinity. So as applying it, it will become negative 6 multiplied by negative infinity, which will be equal to positive infinity. So the overall limit of the said function is positive infinity. Now to properly visualize this graph, let's have this graph of the function. As the function is getting nearer and nearer to 7, but on the left side, we can see that the behavior of the graph increases and it approaches near and near to positive infinity. So the solution we had just reflects the behavior of the graph. Now let's move on to the second example and the final example. The limit of 7x plus 1 all over 8x plus 24 as x approaches to negative 3 to the right. Again, apply the limit theorems. We have the limit of 7x plus 1 as x approaches to negative 3 to the right all over the limit of 8x plus 24 as x approaches to negative 3 to the right. Further simplifying, we now have 7 multiplied by negative 3 to the right plus 1 all over 8 multiplied by negative 3 to the right plus 24. And further simplifying, we now have negative 21 all over negative 24 to the right plus 24, and which will be equal to negative 22 over 0 plus. Let's copy the sign that the function got from the limit, from the approaching limit. So it is 0 plus. And going back to the discussion, it is said that the limit of a certain function as s approaches to a certain number to the right will be equal to infinity. So simplifying, we now have negative 22, 22 multiplied by infinity, which is equal to negative infinity. So that is the limit of the function. And to prove this, we can graph the function and see the behavior of the graph as x approaches to negative 3 and As x approaches to nearer and nearer to 3 but not quite 3 and to the right side of it, we can see that it is going downwards without bound, so it is just sensible that the limit, according to the solution we had earlier, is negative infinity. And that's all for today. Have a productive day ahead.